Good morning, everyone. My name is Phyllis Newbill. I'm the Outreach and Engagement Coordinator at the Center for Educational Networks and Impacts at Virginia Tech. And also, I direct the Virginia Tech Science Festival. I'm really glad you all are joining us this morning. This morning, we have Ms. Thomas's sixth grade class from Czech Elementary School. And on the exhibitor side, we have Adi and Justin, who are going to talk to us about rolling races, the unexpected behavior of rolling objects.
Hello, everybody. My name is Justin, and the other presenter today is Heidi. We're both PhD students in the Engineering, Science, and Mechanics department at Virginia Tech. And we're glad to see you. Thank you, Mrs. Thomas, for setting this up. Thank you, Mrs. Thomas's sixth grade class, for being here today. I'm glad to see that the learning and curiosity can't be stopped by COVID. And so let's begin. So on the left side of the screen, what you're seeing is called the Tower of Pisa, the Leaning Tower of Pisa. It's in Italy, Pisa, Italy. And I just wanted to ask the simple question. If you dropped two objects of different masses, so of different weight, like let's say a monster truck and the monster truck's wheel, or a peanut butter jar, what do you think would reach the ground first?
So they I think both, like there's a mix between the class.
Okay, so some of you think that the heavier object will fall first, and some of you think the smaller object will fall later. But I want to tell you, surprisingly enough, both of them are going to reach the ground at the exact same time. I also want to ask the next question. If I rolled the peanut butter jar and the monster truck tire down a ramp, which one would reach the bottom first? Remember in the previous slide, we just said that if you drop both of them from the tower, that they're going to reach the ground at the same time, right? But now if you roll them down the ramp, which one do you think would roll down first? Which one do you think would reach the bottom first? So some of you said the monster truck tire, some of you said the peanut butter, right? In the previous slide, we said both of them are going to fall at the same speed, right? But now, what's surprising is that if you roll both of them down, the peanut butter jar is always going to roll down faster than the monster truck tire. I want you to think about the last time you went to the park and you were using the merry-go-round. So if you know your friend, let's say your friend is at the center of the merry-go-round and you try to push the merry-go-round, it's a lot easier than trying to push your friend if your friend is at the edge. And similarly, the peanut butter jar, you can think of all the peanut butter being at the center of the peanut butter jar. And for the monster truck wheel, you can think of all the material being on the edge. So actually it takes a lot more energy to push the monster truck wheel than you would to push the peanut butter jar.
So what about a different case where we now have a hollow cylinder and a cylinder that's lopsided, which means that masses are concentrated in one side. So there we have two batteries, massive batteries that are pushed to the end, the other end of the cylinder. So now, what are your guesses? If we roll them down the inclined plane, who will win? As most of you guessed, you see that the cylinder with lopsidedness, which we have batteries on, wins the race. What happens now if we have mass inside the cylinder moving? So what we have is we put rice inside one cylinder and we because it's rice, it's going to be moving all the time in the cylinder. And the other cylinder, we have a hollow cylinder, that's just usual. So let's see what happens this time. You see that although the cylinder with the rice, which is lopsided, it actually loses here. So we see an interesting effect where the rice is trying to impede or kind of slow down the cylinder while it moves. So in summary, for perfectly round objects, we find that hollow objects are slower because for hollow objects, they have more rotational inertia, which means they are harder to roll down. So we have this case where we have a tire and peanut butter. We see that the peanut butter rolls down more, so it wins the race. Sometimes if we have lopsided cylinders, like the two batteries sticking together, or if they're far apart, we see that the batteries that are together win the race because they're more lopsided. And if the masses are moving, then it's more complicated. We would think that they would win, the lopsided case would win, but since the mass is moving, it's trying to slow down the motion.
So if we were to roll down the hill at recess, since all of our mass is like centered, but like some of us are more lopsided than others with our body shape, how would that affect us?
So as we've seen, I think the lopsided one would win, right?
As you're learning about these rotational objects and in the ways that they work, how do you apply that knowledge in the work world?
One thing we've learned is that in space, if we have objects that are different rotational inertia, then they actually spin more, one spin more or one spin less. So if we want to try to control the spinning, for example, in space, then we would have to calculate those rotational inertias of those objects.
Right now, and we're fascinated with the idea of planets exploding and like running into each other in their orbital fields. So kind of like Pluto and Neptune running into each other. Or I watched a video the other day that the moon, if it gets a little bit too close to us, then our rotation will slow down and eventually the moon will explode. So how likely is that to happen because of this? Is it like because of their masses at the center of these objects? Will it take them a long time to slow down? Or could we see an explosion in the next soonish years?
There's a similar situation. Let's say you have a planet like, let's say you have Earth, right? And a few billion years ago, a big asteroid hit Earth. And so what happened is literally a big object actually struck Earth and landed on Earth. So that big little object is like a friend on the merry-go-round. It's now on the edge of the merry-go-round. So actually, if you measured how fast the Earth is rotating, you would have noticed that the Earth slowed down a very little amount, but it did slow down. And just like our simple experiments demonstrated, this principle applies in all situations to any object, to any situation.
You say that it's probably not likely for the moon to explode anytime soon?
Yeah, I think we don't have to worry about that for now. I think we have bigger concerns like COVID.
So what happens if a star explodes? Like because of their mass and how their mass is made, like what happens with that? So how do stars' masses relate to this?
If you think about the entire system and you calculate its moment of inertia about the center where it's rotating, it would decrease, thereby spinning faster.
Well, we are out of time, and I just want to thank you all for being here this morning. We also thank Heidi and Justin very much for that excellent presentation. Have a great day.
Bye, guys.
Thank you so much.
Bye-bye.